An oil refinery converts crude oil into gasoline, kerosene, principally jet fuel, diesel, and some other miscellaneous products such as propane, butane, fuel oil, and fuel gas. Refinery product slates depend on local economics and market needs. For example, American refineries exist principally to maximize gasoline production. On the other hand, European refineries produce significantly more diesel since many European cars run on diesel. In addition, refinery process schemes are different due to local market needs and what crude oil they process. What's shown on our diagram here are largely units typically found in an American oil refinery. Crude oil arrives via pipeline or tanker. The first unit in a refinery is always a crude unit, which separates the crude oil by boiling point through a unit operation called distillation. The vacuum distillation unit is simply an extension of the crude unit. It performs an additional distillation, but this time under vacuum. It's needed because crude oil starts to crack to undesirable products at about 700 degrees Fahrenheit. The temperature is typically found in the bottom of the crude unit. Unfortunately, naphtha, which is gasoline range material, does not have a high enough octane value to be blended directly into the gasoline pool. Therefore, it needs to be further processed in what's called a reformer to upgrade its octane value. That's the operation to produce the 85, 87, or 91 that you normally see on the gasoline pump. The good news is that kerosene separated in the crude tower is suitable directly for use as jet oil or as a heating fuel. Since crude oil contains varying quantities of sulfur, many of the refinery products need to undergo an additional desulfurization process. In our refinery flow here, we show a diesel hydrotreater. While shown for diesel, there are usually a number of different hydrotreaters in a refinery. The fluid catalytical cracker, or FCC for short, is usually the economic heart of an American oil refinery. It converts many of the heavier oils from the bottom of the crude tower and top cuts in the vacuum tower into more gasoline with a high enough octane to be blended directly into the gasoline pool. The alkylation unit takes certain light butane materials produced in the FCC and reacts them together to produce alkylate, a C8 hydrocarbon with a very high octane value. Since an American refinery exists principally to produce gasoline, the coker takes very heavy material that couldn't vaporize in the vacuum tower and essentially cooks it in an operation to boil out any possible gasoline-grade material that's left. What remains after that cooking operation is pure carbon, or coke, similar to charcoal. Hydrocracking is an operation that some refineries have, though not all. It is a very flexible operation that runs at high temperatures and pressures and can take heavy, undesirable materials and crack it down to kerosene, diesel, or even to naphtha if the operation is severe enough. There are also several gas plants throughout a refinery. These recover propane and butane from gases produced in different units. Here it is shown for the crude tower overhead gas. In addition, there is always a final step to clean up fuel gas to remove all sulfur materials so it can be used in your homes. This occurs in the amine and Klaus units. You can learn more about each individual process unit and highlights about specific Agreco applications for those units by watching other videos in this series. In addition, there's a video about the individual properties of crude oil and specific product properties.